Hello everyone, myself Darshane. I'm studying in Sri Venkateswara College of Engineering. My USN number is 1VE23CS043. My class is Aryabhata. Subject is Digital Design and Computer Organization. Subject code is BCS302. Today's topic is Utilization of K-map in Exploring Cause-Effect Relations modeled by partially defined Boolean functions. Utilization of K-map in exploring cause-effect relations modeled by partially defined Boolean function. This paper explores cause-effect relationship modeled by partially defined Boolean functions using a modern, regular, and modular 8-variable K-map. The author present a K-map to test to determine whether a variable is essential for a function and introduce a method for excluding variable from the set of supporting variables. The paper aims to address a dominating unspecified PDBF to obtain all its minimal sets of supporting variables without reporting to integer programming techniques. A running example. Hexadecimal numbers considerably facilitates the conversion of truth table in the table 1 to the conjuring map in fig 1. The configuration is simply located at the horizontal coordinate and the vertical coordinate. Note that the map input is given in terms of shown designation of the y and z variables or equivalently by the corresponding values of and which are reduced from equation 1 and 2. A few remarks about the running examples are in order. Table 1. The truth table of running example adopted from the truth table expresses a single endogenous factor in terms of 8 exogenous factors, expresses a dichotomous binary variables that can be compressed into two hexadecimal variables h1 and h0. Only 7 out of 256 lines are confidence specified. Here is the table 1 shown in the figure. The problem of cause-effect relationship. The paper focuses on the problem of identifying the minimal subset of possible cause of given effect among a larger set of factors, including all potential causes along with many other factors. The problem is particularly relevant in fields like artificial intelligence, machine learning, and qualitative comparative analysis QCA. Limited observation. The author emphasizes that when only partial observations are available, no method can provide definite answers. However, they believe that even then the cause effect relationship can be narrowed down sufficiently to provide sustainable guidance. NP-hard problems. The computational problems arising in this framework, such as deriving minimal sets of supporting variables or finding all irredundant sums of each other of these sets are NP-hard. However, in most application of interest, the number of explanatory factors and observations are accepted to be reasonably small. Third one, QCA and digital circuit design. The problem addresses in paper is similar to those addressed by QCA, but it has subtle difference with the problem of digital circuit and design. Construction and use of K-map. The construction of K-map is based on repeated applications of Boltzmann expansion. This expansion expresses a Boolean function in terms of its two subfunctions, which are obtained by restricting the functional to 0 and 1 respectively. The paper discusses how the K-map can be split into two halves representing the internal and external domains of the variable. The author explains that a variable can be excluded from a set of supporting variable if certain conditions are met, including the absence of contradictory mirror image cells and appropriate assignments to don't care cells. First, Boltzmann expansion. The construction of K-map is based on repeated applications of Boltzmann expansion, which expresses a Boolean function in terms of its two subfunction. 2. Map folding. Various type of map folding allows the replacement of n variable map to n-1 variable maps. Variable expansion. A variable can be excluded from a set of supporting variables if certain conditions are met, including the absence of contradictory cells and appropriate assignments don't care cells. Conjuring map solutions of the running example. The paper presents a regular modular 8 variable K map to solve a running example. The author demonstrates how the map can be used to identify minimal subsets of supporting variable by systematically manipulating the don't care cells to make the outcome function independent of certain variables. This process leads to discovery of several minimal sets of supporting vehicles variables, each with its own set of iridium distinctive from IDFs. Here is the 8 variable came up. This figure shows. Now, minimal sets. The author demonstrates how the map can be used to identify minimal sets of supporting variables by systematically manipulating the don't care cells to make the outcome function independent of certain variables. Urinating IDFs. For each minimal sets of supporting variables, the author employs standard map methods for extracting prime implicants to construct all IDFs. Map reduction. The author avoids the task of drawing prime implicate loops on the initial 8 variable and postpone the task until the dramatically reduced in size. Consequences of qualitative comparative analysis QCA. The paper highlights the implications of the approach for QCA. The author argues that the two often strong result claimed by QCA adherents need to be checked and synchronized. They suggest the more observations are needed to narrow down a possibilities and declare the number of candidates IDFs. The author emphasizes the giving preference to a certain IDFs over others should be context specific rather than the tool specific. Strong results. The author argued that the two often strong results came by QCA adherents need to be checked and synchronized. More observations. They suggest that more observations are needed to narrow down the possibilities and decrease the number of candidates' IDFs. Context specific preference. The author emphasizes that giving preference to certain IDFs over others should be context rather than the tool specific. The K-map, a power tool. The paper demonstrates the power of K-map as a tool for exploring cause-effect relationships in partially defined Boolean function. The author shows the map can be used to systematically identify minimal sets of supporting variables and construct all redundant IDFs. This approach offers a valuable alternative to integer programming techniques and provides a more intuitive and visual understanding of the problem. Visual representation. The K-map provides a visual representation of the Boolean function, make it easier to understand the relationship between the systematic approach. The paper presents a systematic approach for identifying minimal sets of supporting variables and constructing IDFs. Intuitive under the K-map provides an intuitive understanding of the problem, making it easier to understand the concept and apply the method. Importance of rigorous methodology. The paper emphasized the importance of rigorous methodology in analyzing cause-effect relationship. The author argued that the two often strong results claimed by QCA adherents need to be checked and synchronized. They suggest that more observation are needed to narrow down the possibilities and decrease the number of candidates IDF. This highlights need for careful interruption of result and importance of considering multiple radius methodology. There are three types of methodologies: radius methodology, careful interpretation, and multiple perspectives. The future cause of effect analysis. The paper suggests that the K-map approach offers a valuable contribution to the field of cause effect analysis. The author believes that this method can provide more radius and understanding of complex relationships, particularly in area like QCA. They encourage further research and development of this approach to enhance its capabilities and broaden its application. Rigorous understanding. The author believes that this method can provide more rigorous and nuanced understanding of complex relationship. Broader application. They encourage further research development of this approach to enhance its capability and broaden its application. Future research. The author believes that the K-map approach of a valuable contribution to the field of cause effect. Conclusion. The paper concludes by emphasizing the importance of using research methodology and considering multiple perspectives when analyzing cause effect risk. The author believes that the K-map approach offers a valuable tool for the purpose and encourages further research and development to enhance its capabilities and broaden its applications. Thank you.